So far in working with factoring polynomials, we have done greatest common factor, which works on any size polynomial where there is a common factor, and then grouping works on polynomials with four terms that we can divide into two groups of two that may have common factors. Now, what we're going to look at in this lesson, my name for it is trial and error. But you will see, because of the kind of problems we have, that you really probably will not error. As you learn more about factoring, maybe in future courses, then you will possibly have to do some almost guess and then check. Trial and error works exclusively on trinomials, and it is the reverse of FOIL, which means that we need to do a little bit of review of FOIL. Remember, FOIL is used to multiply two binomials. So let's take a look at, say, x plus 2 times x plus 5, the product of those. First, product of the first is x squared. The outer product is 5x. The inner product is 2x. They're both positive, so I add them up for 7x. The product of the last is positive 10. Now, please notice several things. The first term in the trinomial answer comes from product of the first. The last term in the trinomial comes from the product of the last. The inner or middle term comes from the outer product plus the inner product. All right, so we've looked at that one. Now, how would it be different if I had x minus 2 times x minus 5? Well, the product of the first would still be x squared, so there's no change there. The outer product is negative 5x, and the inner product is negative 2x, which gives me negative 7x. The product of the last, since it's negative times negative, gives me plus 10. So, if you notice that the first and the last terms were the same in these, but when these were both minus by subtraction in binomials, you ended up with the outer and an inner which were both negative for a negative middle term. All right, and you probably know where I'm going with this. In my next example, what if I multiplied x plus 2 times x minus 5, where the signs were different in the factors? The product of the first would still be x squared. The outer product would be negative 5x. The inner product would be positive 2x, and because one was negative and one was positive, I subtract and keep the sign of the bigger one for minus 3x. The product of the last, a positive times a negative, gives me negative 10. So when the two signs are different, I end up with taking the difference of the outers and inners and keeping the sign of the big one. All right, one more. What if I had x minus 2 times x plus 5? How would that differ? Well, the product of the first would still be x squared. The outer product would be positive 5x, and the inner product would be negative 2x, so I still take the difference, but this time the big one was positive, so I end up with plus 3x. Then negative 2 times positive 5 is still minus 10. What we're going to be looking at for signs is we're going to be starting with these trinomials. Our job in factoring is to rediscover what the factors were. So let's talk and see if we can make some summary statements. If the last sign in the trinomial is positive, then both of the signs in the factors match the middle term. If the last sign is positive, then both of these signs match the middle. If the last sign in the trinomial is positive, then the two signs in the factors are the same and they match the middle term. If instead the last sign in the trinomial is negative, you will always get 1 plus and 1 minus. If it's minus, there will always be 1 plus and 1 minus. Now, does it matter which numbers get which signs? Yes. The bigger number will match the sign of the middle term. Now, that was a lot to talk about and a little bit hard to just remember unless you start practicing. So let's start practicing. If a polynomial cannot be factored, then it is called prime. All right, first trinomial. I have x squared plus 9x plus 8. I check and I notice there is no common factor. And I count 1, 2, 3 terms, and if it's a trinomial, then I'm going to look at trial and error. I'm going to see if I can undo the FOIL. So I will write down my two binomial factors. The rules on the signs are very helpful. If the last sign is positive, these two have to both match the middle term. If this is positive, both of these signs match the middle term, which means they are plus and plus. That's going to be helpful. The first times the first gives me x squared. Well, that's pretty easy. X times x. Now the last times the last gives me 8. Well, there's more than one way to make that happen. 1 times 8 gives me 8. 2 times 4 gives me 8. Both of those will give you an 8. But only one of them is right. How will you know? You'll check the outers and the inners. The outers and the inners have to add up to be 9. Which of these can add up to be 9? Hopefully you see it's 1 and 8. So put them in there, but please check them. The outer product is 8x. The inner product is 1x. Those do add together to be 9x. And everything works out the same. You check x squared, x times x is x squared, outers and inners add up to be 9x, 1 times 8 is 8. Those are the factors. All right, let's look at another one. It's another trinomial of x squared minus 10x plus 24. There's no common factor. The trinomial tells me to try to undo FOIL using this technique I call trial and error. All right, signs. If the last sign is positive, then both of the signs in the factors match the middle term. So these are both minus. If the last sign is positive, both terms match the middle. These were both pluses. All right. I know I have x and x. The last times the last gives you 24. Now there's a lot of different factors to 24. 1 times 24 is 24. Does 2 go in there? Yeah. 2 times 12. Does 3 go into 24? Yes. 8 times. Does 4 go in there? Yes. 6 times. 5 doesn't. Does 6 go in there? I don't have to write it down because I already have a 6. So these are all my combinations. Any one of these will give me 24. But which one will give me an outer and an inner to add up to be 10? The answer, I hope, is obvious, to be 4 and 6. So x times x is x squared. Outer product is negative 6x. Inner product, negative 4x, which gives you negative 10x. And negative 4 times negative 6 gives me plus 24. Those are the only numbers that will work. You can have x minus 6 times x minus 4, That would be using the commutative property, which says the order of the factors doesn't matter. Next one, I have x squared minus 14x plus 49. There's not a common factor to all of them. It's a trinomial, so I'm hopeful that I can find two binomial factors. The last sign is positive. Both of the signs match the middle term. I need an x and an x. I need factors of 49. 1 times 49. The only other thing I can think of is 7 times 7. Which of those gives you an outer plus an inner to add up to be 14? Well, it's 7 and 7. And those work. X times x is x squared. Outer product, negative 7x. Inner product, negative 7x for negative 14x. Negative times negative is positive 49. This is the answer that my math lab would be expecting right now. Later, you might recognize that this is x minus 7 squared. But for now, you can just write it in as two factors. All right, let's look at some more. I have x squared minus 4x minus 45. No common factor. Let's see. Now, for the first time in my examples, the last term is a negative. When it's a negative, you must have one plus and one minus. That's the only rule. If the last sign is negative, you must have one of each. When you get the two factors, the bigger number must have this sign. All right, so I know x times x gives me x squared. I have factors of 45. Well, 1 times 45 is, let me make that better. 1 times 45 gives you 45. 2 doesn't go into it, but 3 does. 3 times 15. 4 doesn't, but 5 does. 5 times 9. 6 doesn't. 7 doesn't. 8 doesn't. Up, back to 9. All right, so I have all the factors. Please notice this. This is the first example where the outer product is going to be negative, the inner product is going to be positive. So they're not going to add up to be 4. They're going to have a difference of 4. 5 and 9 have a difference of 4. The bigger number, which is the 9, must be with the negative. Smaller in the other spot. Let's check it. X times x is x squared. Outer product, negative 9x. Inner product, 5x. That would give you negative 4x. The product of positive 5 times negative 9 gives you negative 45. Next one, the x squared plus x minus 2. It is a trinomial with no common factor, so I'll write down my two parentheses, trying to undo the FOIL. The signs, when the last sign is negative, you always get 2, one of each, one plus, one minus, and the bigger factor will get a plus this time. All right, I know it's x and x. Factors of 2. Now 2 is a prime number, which means I only have one set of factors, 1 and 2. Outer will be negative, inner will be positive. They have to have a difference of implied 1. Yeah, 2 and 1 have a difference of 1. The bigger number, the 2, must go with the plus sign. So put the 2, put the 1. You're checking them, so if they're in the wrong spots, you'll erase them and change them. X times x is x squared. Outer product is negative 1x. Inner product is positive 2x. Those have a difference of 1x. And 2 times negative 1 is negative 2. Next, I have x squared plus 40x minus plus 17. All right. Last sign is positive. That tells me both signs are pluses because of this sign. So I have x and x. Factors of 17. Well, 17 is a prime number. All you have is 1 times 17. Will the outer and the inner add up to be 40? Can 1 plus 17 equal 40? The answer is no. You cannot factor this. This is prime. Now, not all primes are as easy to identify as this one is, but the factors of 17 are 1 and 17. Those cannot add up to be 40, so this cannot be factored. Let's look at some more. I have x squared plus 17xy plus 72y squared. One thing that's really different about this one is the x's and the y's. So we'll look at that in just a minute. How about signs? Last sign is positive. What does that tell us? Both signs match the middle term, so they're both pluses. To get an x squared, I need an x times an x. Now, I'm going to be working on getting this 72, but this time it's 72y squared. So no matter what the numbers are, they will have y's with them. All right, now, factors of 72. There's my outer, there's my inner. I have 1 times 72. 2 goes in there 36 times. 3 goes in there 24 times. 4 goes in there 18 times. 5 doesn't go in there. 6 goes in there 12 times. 7 doesn't go in there. 8 goes in there 9 times. It might be useful to have a little calculator sitting around so that as you say, does 1 go in, does 2, does 3, does 4, you can test them if you need to. Now, these are going to have an outer and an inner product that have to add up to be 17. All right, looks like it's going to be 8 and 9. Doesn't matter where you're going to put them because they were both positive. Let's check it. X times x is x squared. The outer product is 9xy. The inner product is 8xy. Those add up to be 17xy. Product of the last is going to be positive 72, and y times y is y squared. Don't forget the y's. Number 8. I have a squared minus 12ab plus 35b squared. It's a trinomial. The last sign is positive, which means both signs match the middle term, minus, minus. I'm going to need an a times an a to give me an a squared. Whatever numbers I choose, they're going to have to be with the b's. All right, to get a 35. 1 times 35 gives me 35. 2 doesn't go in there, 3 doesn't, 4 doesn't, 5 does, times 7. I think that's it. Which of these will give me a sum, an outer plus an inner, of 12? 5 and 7. It doesn't matter where you put them. Let's just put them in there. A times a is a squared. Outer product, negative 7ab. Inner product, negative 5ab. Adds up to negative 12ab. Negative times negative is positive. 35. B times b is b squared. I always recommend that you check by FOIL. A few more examples. Next one, I have x squared plus 16x plus 60. Trinomial. Last sign is positive. That means both signs match the middle. They're both pluses, an x and an x. Now, before I write all these down, 60 has a lot of factor combinations. You just think about it. Can you think of two factors? Blank times blank is 60, but they add up to be 16. Let's see if you're right. I have 1 times 60 gives me 60. 2 times 30. 3 times 20. 4 times 15. 5 times 12. 6 times 10, and I think that's it. Will any of these add up to be 16? Yes, 6 and 10. Did you get it right? That gives me x squared, outer product of 10x, inner product of 6x, adds up to be 16x. 6 times 10 is 60. Last one, I have m squared plus 11n plus 21. It's a trinomial. That means that I look for the two binomial factors. Last sign is positive, tells me both signs match the middle. I need an n times n gives me n squared. Factors of 21. Well, 1 times 21, 2 doesn't go into it, but 3 does 7 times, and I think that's it. Which of these have factors so that the outers and inners will add up to be 11? Well, neither of them. This is also a prime polynomial. All right, so you have several problems to work on. You should have 10 in your assignment, and I hope these examples have helped you.